Today we're going to be talking about the tan and cotan graph. So to start, just pause the video and copy down this generic tan formula, and this is a generic tan graph. Okay, so take a minute, copy that down. Now that you've copied it down, we want to notice a couple of things about this tan graph. Number one is going to be the normal asymptotes of any tan graph are pi over 2 and negative pi over 2. So make sure you highlight that. That's super important. So that's why you see this negative pi over 2 here and this pi over 2 here. For any tan graph, that's like the standard asymptotes you're going to work with. The second thing to note is the period is going to be a little shorter. The period for tan is actually just pi over b rather than 2 pi over b. For tan, the period is much shorter. And right here, we're going to mark up this graph. Here to here is only one period. This graph continues indefinitely. So imagine this cubic curve or just go in both directions forever, dot, dot, dot. Okay, so that's going to be your typical standard tan facts. And there's one more thing I want to note here. I'll do this in blue. I want you to note that tan normally increases. Meaning if you read the graph from left to right, notice how it's going to go up. That's what it means to increase. So that should be enough to work with these first graphs. I'm going to show you how to work step by step. So for this first one, I'll put step 1. What you want to do first is find the asymptotes. And how you do that is you grab this bx part, in this case x over 2, and you make it an equality. And what we're going to say is it's normally between pi over 2 and negative pi over 2. Okay, so again, that's from your normal asymptotes. That's from this fact right here. Now that we have that, we're going to solve for x. So simply multiply by 2. So x is between pi and negative pi. What you just found are your new asymptotes. Now step 2 is going to be just the graph. Now the graph, there are a couple facts we need. We need the a value. Some people call it amplitude. It's the same idea as a sine and cosine. It's just absolute value of the number in the front. So in this case, it's 2. And then the period, just do our new formula. That's pi over b. So in this case, it would be 2 pi. And in case you're wondering how I did that, just recall you have pi over 1 over 2, and that would be 2 pi. So now that we have that, we're going to graph it by first starting with your asymptotes. So put those down first. Then I'm going to put this line here. Put this line here. So there's an x and y axis. Put your new asymptotes down, negative pi, pi. And just like your sine cosine graph, scale between them evenly. So this is 0, that's pi over 2, that's negative pi over 2. Now we're going to use this a value to scale the top and bottom. So just go up 2, down 2. And now we're going to graph the standard tan points. So if you look at this, there are 3 points you want to consider. This middle, the bottom left, and the bottom right. And that's going to be your normal points. That's all assuming a is positive. So in this case, this number right here is positive. So let's put that down. It's going to be the positive points here. And notice how it is increasing. So draw your cubic curve like that. We'll label it. And there it is. Now for domain and range, I gotta show you how to do this. Not quite that simple. The range is clear. It goes up and down forever like that. So we can just write all real numbers here. Now the domain, we're gonna write x such that, hopefully you recall that from 2b, x such that x cannot be, and for this one, I'm gonna write pi plus 2 pi k. So what I'm saying is, it's all values of x such that x cannot be pi, so this is any asymptote. So I could have picked negative pi, I could have picked 3 pi. You should really just pick one of these two that we found here. And notice this value right here, we've found that earlier, that's right there, that's the period. And that's because that's the distance from here to here. That's one period. So we're saying the domain of this function is everything except for all these asymptotes, pi plus 2 pi k. And there we go. First example is done. For our next example, you're going to see that this equation has a few things going on. There's a negative 5 here, there's a pi over 3 here, and there's a negative 4. So quite a few things happening. So let's go through it step by step. So step number 1 is going to be the same as what you've been doing. We're going to find the new asymptotes. So let's grab the bx term, and we're going to put it between negative pi over 2 and pi over 2. Let's multiply this by 3 over pi, and now we can see that x should be between 3 over 2 and negative 3 over 2. Okay, so right there, here are the new asymptotes. Now let's graph it. The relevant information is our a value is 5. The period is going to be 3. And there's actually a midline. There's a midline of negative 4. So this will clearly be a little more complicated. So I still want you to approach it the same way. You're going to start with the asymptotes. So I'm just going to put my asymptotes right there. And what's tricky about this is there's a midline. So some people just do that last, like they'll graph it and shift it down 4 at the end. What I'm going to do is put a dotted line in the middle, and that's going to represent our negative 4. So I'm going to put that, I'll put that right here. That's going to be minus 4. Now our asymptotes, I'm going to put that underneath. This was negative 3 over 2, positive 3 over 2. Which means right in the middle, that's our 0 line. And then if this is negative 4 in the middle, if we go up 5, that should be positive 1. If we go down 5, that should be negative 9. And that would also mean our x-axis is right about here. And I'll put a line right here to note that. Okay, let's graph it. So we have a point in the middle. Now normally these points are going to go up, meaning they increase. But because this is negative, this is going to decrease, which means you just flip your points like this. And I'll move that negative 9 over. And notice I forgot to scale these, so I'll put this down really quick. If that's 3 over 2, this should be 3 over 4 and negative 3 over 4. And there we go. Let's put our cubic curve in. And let's write those points down. Negative 3 over 4, positive 1. 0, negative 4. And 3 over 4, negative 9. Now for domain and range, again, the range is the easy part, that's just everything. And the domain is going to be all x, such that x cannot be, pick an asymptote. I'll pick 3 over 2 plus the period k, and the period is 3. And there's our tan graph. So now work on the tan practice problems. Once you're done, you're going to go to the cotan part of the video. Now that you've done the tan problems, you're ready for the cotan graph. So take a minute, pause the video, and copy down the standard cotan graph along with the formula. Once you're done, unpause the video. So now that you've copied down the standard cotan graph, let's talk about the normal asymptotes. So for tan, it was negative pi over 2 and pi over 2, because that's where tan is undefined on the circle. For cotan, it's undefined at 0 and pi. So you're going to see that those are your typical asymptotes. The period formula is the same as a tan. It's simply pi over b. And think about if tan normally increases, cotan is the reciprocal, which means cotan will normally decrease. And that's all we really need for now. So let's do a couple graphs here. The steps are identical to what we were doing earlier. We're going to find our asymptotes, and it's really the same process. You put pi over 2x here, but you put it between the normal asymptotes for cotan. So in this case, it's right here. You use 0 and pi. Now notice cotan graphs are much easier because of that 0. When I multiply by 2 over pi, that 0 is still there. You have x, and this is going to be 2. So there's our new asymptotes. Step number 2 is the same. We're just going to graph it. Our a is a half. Our period is 2. Notice how this is matching here for the cotan graph. That's pretty handy. And now let's graph it. I'm going to put a solid line because 0 is an asymptote, so that's pretty useful. The other asymptote is 2, so let's put a dotted line. This is 2. Let's scale it. 1 half 3 over 2. We're going to go up 1 half, down 1 half, and the points are pretty similar to tan. You always have your middle point, and cotan normally decreases. We can see that that's a positive half, so it will just decrease like a normal graph here. We'll put our wave in. Let's label 1 half, 1 half, 1 0, 3 over 2, negative 1 half. Our domain is all x such that x cannot be. Some people like to write 0 and then put plus the period k, so 0 plus 2k. Clearly you don't need to write that. You could have written this, x such that x cannot be 2k. And the range is going to be everything. So the range for these is quite easy. Let's try one more. So it's 2 cotan 2 pi over 3x plus 3. So first step, the same thing. 2 pi over 3x, that's between your 0 and pi. Let's multiply it by 3 over 2 pi. So 0 is between x, which is less than 3 over 2. So there we have it, our new asymptotes. Step number 2, our a value is 2. The period is 3 over 2. And your midline, that's 3. So start the same way. We're going to put our asymptotes down. Let's put a 0 line right here. And I'll put the other asymptote. And I'm actually going to put the midline right here. And you'll see why this, I think, will make it much easier. The midline is 3. Let's use the a value. So go up 2, that's 5. Down 2 is 1. Which means our x-axis is right below. So that's more for a reference here. But you always need to put the x-axis and y-axis in any graph you do. And now that we know that, we can see that the asymptote is 3 over 2. So I'll note that here in red, 3 over 2. And if I just continue the scaling, that would mean this is 3 over 4, 3 over 8, and 9 over 8. Now let's put our points down. There's your middle point. We can see it's a regular cotangent graph, so just make it go down or decrease. And let's draw it in. So now let's label these points here. That's 3 over 8, 5. 3 over 4, 3. And our last point here is going to be 9 over 8, comma 1. Now we do the domain and range. You clearly see the range is everything. And the domain is going to be x, such that x cannot be. I'll use 0 as an asymptote. 0 plus the period, which is 3 over 2k. And that's it.